Welcome, everybody, to the American Space Museum. I'm Marquette, and we're so glad you're with us to stay curious and stay star curious. As once a week, we bring you a little backyard astronomy with me, Stargazer Mark. It's been cloudy for a couple days, so we're going to go inside in this, not make a patch quilt. This is a patch quilt of what our sun looks like. You see the big sphere around me, the edges off my shoulder. And each of these squares represent a different way that we look at the sun with today's 21st century modern day technology. So we're going to enjoy revealing how the sun is a very active star. That's right, just like all the twinkling stars in the sky, the sun is just an average Joe Schmo star. Actually, it's kind of a small star compared to the whole mainstream of stars out there. But we're just going to talk about our one star, the sun, which affects the Earth here because last week a geomagnetic solar storm brought down over 40 Starlink satellites that were launched just days before. This solar storm originated on the sun 93 million miles away, and in a very simple term, some of the flames off of the sun, the plasma, ejected out at 1 million miles an hour. But 93 million miles away, it took, over 90 hours to reach the sun, almost 4 days before it hit. And when it warmed up the atmosphere, that reached up and grabbed those satellites in an atmospheric drag before they could be pushed up higher. And we're going to explain a little bit about a solar cycle that we know has been happening for 400 years since Galileo first looked at the sun and said, it's got spots on it, which was almost blasphemy that back in the time. So that's what we're going to talk about today on Facebook, YouTube, Twitch, and Spotify video. And hopefully maybe you'll be enjoying this in audio on YouTube, or no, audio on Google and Apple. Meantime, I got Marty Winkle with me, my cameraman, co-producer, working our Streamlabs studio here in the middle of our museum. We're just 9 miles from where Artemis is going to go to the moon, and we've got some visitors here. We're glad to have y'all here. Some of our harvest hosters there, taking in a little bit of Star Curious on Stay Curious today. So, Marty, let's look at a pretty picture here of a sunrise. There, like Pad 41 over there at Cape Canaveral Air Force Base. Let me get a little rocket fuel here. Oh, nice and strong today. And the sun, of course, the most important object in the sky. The ancient cavemen knew that it moved through the sky, that it brought warmth. But then certain times of the year, it wasn't as warm as other times of the year. And this is where man started thinking and evolving in his cerebral thinking of what he is doing and where he is. And it's taken us a long time to figure out that the Earth is going around the sun and not the opposite, because it's logical to think, well, that's moving, every day from the east to the west. If you're facing south, left to right. And but we're going to talk today about the science of the sun, and not all of the dogma and the religion at 1,100 miles an hour, and everything's going to the opposite direction. Just like you passing a faster vehicle on the highway, it looks like it's going backwards for a little while. That's the illusion of what's going on here. But you never see the sun when you're looking to the north, like towards Canada, or down here in the south. I'll say that you never see it looking towards Jacksonville. You're always looking towards Miami, all right, when you see the sun, the moon, the stars, because the Earth is tilted and our axis is knocked over on the side, and that means that everything is not up and down or so. 2 million miles away. In the summertime, we're about 94.5 million miles away. But it's warm, it's hotter, only in the northern hemisphere, okay? All my friends in Australia and New Zealand, they're experiencing summer right now and enjoying it. So hope you're watching down there, Dean Salzwedel. And we've got, my friend in Pomona, Australia there watching. And let me have a sip of coffee here to refresh my memory. So when you buy a house, and in particular if you want plants to survive or put solar panels on your house, you're going to want that part of the house facing to the south. I'll talk about the sun as seen here by an astronomy friend of mine, Steve Rissmiller. This is a photograph he took from his backyard with a special telescope and a special filter on that telescope and then a special camera. You're looking at a $3,000 to $5,000 investment in equipment. Areas are sunspots, and at the edge you see some prominence, as we call them, or flames licking off. All those dark areas are, in a sense, prominences or flames that are licking off of the sun. And here is a solar prominence that Steve took, Steve Rissmiller, just up here in Mims, Florida, about 10 miles from where I'm sitting. And this is a fun thing that amateur astronomers love to invest in and do because the sun changes every day and there's all kinds of techniques and so forth involved. And here's one from John Small, also a club member, that also shows the flames, the prominences coming off. And these prominences are taller than the Earth, is. That's probably 2 Earths diameter, those little flames on the left licking off. And then you see 2 small sunspots. Sunspots are geomagnetic storms that are created by the magnetic fields of this nuclear reaction going on that all stars go through. A star is nothing more than an atomic bomb where fusion is turning hydrogen into helium. And we are experiencing the energy in many forms of energy, from X-rays to white light. And we have several satellites that were launched over here at Kennedy Space Center and Cape Canaveral Air Force Space Force that are keeping us constant 24/7. There's telescopes on the Earth and satellites orbiting the sun and in between the sun and the Earth that are bringing us back these amazing photographs of, you see, solar plasma being lifted. This heats up the atmosphere of the sun hotter than the surface. The surface is only around 6,000 degrees hot, but the atmosphere, called the corona, can be 1,000,000 degrees hot, something we still don't understand and need wonderful young people to get involved in. League, and she's involved with the ALPO, which is the Astronomical League of Planetary Observers, and they observe the planets and the sun. This was taken by Solar Dynamic Observatory, a very important satellite that takes amazing images like this of the sun every day. So the sun is a variable star. It varies its brightness minutely, and it varies its energy output in an 11-year cycle. All right, here's from 1996 to 2006, over an 11-year period, showing you the sun in what we call hydrogen light, where in 96 there's not much activity going on as far as the bright areas being hot spots, where these magnetic storms are occurring along electromagnetic lines and throwing stuff out into the solar system. In there, 2011, when we peaked 21 years ago, all right, the last peak of a solar cycle, we are headed now to 2020. It was so very active there. It didn't change in size. This is a graphic illustrating the activity on the surface of the sun. Now, of course, I'm going to show you some more graphs. On the left is ultraviolet light, where hydrogen alpha dwells. And on the right is sunspots that you see with our naked eyes. If I could look through a telescope and show you what it looks like, and you see in 2002, the same time frame, you get the idea where the bright areas are. That's where dark sunspots are. The ultraviolet light is what we're going to see with the Webb telescope. This is sort of, it won't look at our sun, but it'll look at other stars like the giant Betelgeuse in Orion. Energy areas and what's going on in the sunspot, which are cooler areas of the sun, and in contrast, they look darker. Now, here is the boring science, but from 1985 to 2020, we've had 3 solar cycles, where in 5.5 years, it peaked to 300 sunspots visible on the surface during one complete rotation. which takes 33 days. The sun orbits, it rotates a day on the sun's about 33 Earth days. To 1995, when there weren't many sunspots, then it peaked again in 2001. We just went through a low area of 2010, a not as high solar activity in 2015, and we've just leveled off to what we call a low solar minimum. We've been waiting for years to come out of no activity of sunspots on the sun to it's starting to increase. With some graphics as well as a photograph showing you when the sun reaches a solar maximum, it throws off more things into the solar system. And the gravitational attraction of the planets draws it in like a magnet of electromagnetism. And it enters our poles because just like a magnet, our poles are magnetized north and south pole, okay? Just like the sun has a north and south pole. And when this hits our Earth's atmosphere, the friction with the plasma from the sun and the electromagnetic energy it's dealing with, and our atmosphere high up, 200, 300 miles high, starts creating aurora. And astronauts orbiting 250 miles high see the aurora beneath them and over the poles, and it can extend down, of course, over the planet. And as we see the aurora comes in on the poles and can come down, but it usually sticks around the polar areas, and you don't see it down like in Florida. It has to be a very bright geomagnetic storm to do that. And that's what aurora is, and there's trips that you can take in Scandinavia to see aurora all the time, and they're going to get better as our solar activity is increasing in this 11-year solar cycle. Here's another graphic showing you on the right is the magnetic field of the Earth, and the solar wind is pushing our magnetic trail into space. All right, this is just not planets. Mercury's been magnetic field, but we've got a magnetic field, and the solar wind was one of the first experiments Apollo 11 put on the moon. You remember Buzz Aldrin and that piece of aluminum fit open for about 2 hours so that they could get particles off of the sun that were going through the lifeless atmosphereless of void of the moon. The moon has no atmosphere. It's very, very super thin, but nothing that would stop the solar wind from hitting that. And that was a very valuable piece of scientific investigation, that aluminum foil that they deployed on Apollo 11 over 52 years ago. But this is how it looks. If you could see what was going on, our Earth is protected by our magnetic field from these horrible solar rays that moonwalkers, when the solar peak is going on in 2025, 26, in a few years, they could be endangered by solar flares. Into 2000, where the sun turns off and on in this solar cycle. What causes this to happen? We don't know. Why is it so regular? We don't know. But we record it, and we know that we are beginning to have a new solar maximum. All right, to talk about that solar maximum real quick here before I get into the telescope of that, let me go back to this, is activities the Earth briefly to where when things get hot, they expand. So the Earth's atmosphere expanded slightly. It doesn't have to be consistent. It can be in lumps. It can expand over North America and not over China, for example, depending on where this coronal mass ejection hits. And it's got 93 million miles to travel to the Earth. So there's a great website called Space Weather that predicts all this. And we're going to have more of these activities. But what we need to pay attention to is that as we ramp up to a solar max that's going to peak in about 2028, what's going to happen on Earth? Now, I warn you, 33 years ago, during a solar max of 1989, the entire province of Quebec, Canada, suffered an electrical blackout because of a solar storm, all right? On March 10th, 1989, astronomers saw a powerful explosion from the sun, all right? When it hit the Earth on Monday, the 12th, It was so violent that there were northern lights auroras seen in Miami, in Cuba, unheard of, seeing the wonderful reddish glow of electromagnetism in our atmosphere. As far south as Miami, that's unheard of. But the geomagnetic storms, electromagnetic energy went into the ground and erupted beneath North America around Quebec in a power grid it was attracted to. And in 2 minutes, the entire Quebec power grid was wiped out. Millions of people were without warmth in their homes in March. The blackout caused school closure, businesses to close. Montreal Metro shut down, and it affected the New York Power and New England Power lost voltage at the same time. This can happen and probably will happen in our foreseeable future. Marty, I've scared someone enough that they've got a comment. Let me juice up here.
Yeah, Christopher Mick mentioned that the greatest solar activity than anticipated led to earlier than planned deorbit of Skylab.
Exactly right. Thank you, Christopher Mick, watching in Wisconsin there. Another solar maximum was in about 1974. Let's see if I can go back to my graphs there. That's 85. Okay, so you could see that it heated up the Earth, and that's what brought down Skylab ahead of schedule. Okay, this is going to mess with us, folks. All right, because we are just Earthlings on this planet, and this wonderful shell of atmosphere and ozone and magnetic field and so forth is really a blessing. Mars doesn't have a magnetic field like that or ozone layer. You're going to be exposed on the surface of Mars to the full brunt of solar flares, all right? And it is like being exposed to X-rays. In fact, airplane pilots that go regularly over the Atlantic and the Pacific have on them a gauge of how much radiation they're receiving from the sun, and they are limited in their lifetime to how much radiation they can keep. And this spaceweather.com keeps track of those radioisotopes on certain flights, regular flights around our world. So hope, there's not, in fact, in 1989, Christopher Mick and the Usiak brothers are watching, I'm sure. NASA's Tracking Data and Relay Satellite number 1 actually tumbled out of control for several hours, and communications and satellites had over 250 anomalies in March 12th. Powerful. It was kind of they were in the wrong place at the wrong time. So, Marty, can solar flares destroy the Earth? No. They can mess up power grids, but they're not going to just blow up the Earth like a science fiction movie would have you believe. Can solar flares hurt humans? You better believe it. We're going to have our GPS, global positioning systems, our communications, our cell phones, all of this microwave stuff that we rely on. It's going to get messed with, I will guarantee you here, in the next 5 years because of the increase of solar activity. Because the last solar activity that we had, or the increase, in 2011, you did not have as many dependency on what we're doing now. And think of these electronic cars. Could a solar flare destroy a car? Yes, theoretically, it could redundancies we have on some GPS and other electronics. Can it fry electronics? Absolutely. The phenomenon can end up destroying electronics because it creates a new current along otherwise passive lines. In the greatest event that we've ever seen recorded, happened in 1859, all right? Think back right before the Civil War. And we know that happened by science. A scientist called Carrington, and this is called the Carrington event. He spent a lot of time recording this. The auroral display, looking at the sun, it's hot. It's like, of course, the magnifying glass that we played with out in the schoolyard, chasing ants around with or lighting fires on a piece of paper. It'll do that. But if you use it properly, and don't point it long duration, you can project the image onto a piece of paper. And it's very easy to do. you have the cardboard collar to shade so you can see the paper. Here is a modern day version of it with a telescope that has a, now this is using white light. You see at her hands is the image of the sun there, and you clearly see sunspots. And you could make a quick sketch and just outline on there what the sun looked like, and day by day follow the sunspots moving. And they're along the equator. They're above and below the equator. They're never up by the poles for some reason. But this will get hot, though you could be where Christopher Mick is, and it's 25 degrees outside. I guarantee you this your telescope will get hot inside. So move it frequently, but it's a safe way to look at it, and use caution. Or a reflecting telescope like the one here. It is not projecting that finder scope. It's actually projecting a big screen on a screen, the sun. I projected the sun on the side of a White House. Okay. And it's really cool to see that in groups and so forth. But once again, the sun's moving, and when I did that for a school group, it was starting to get smoking in my telescope because as the sun moved, the mirror put the image on the side of the scope or started burning. But so be careful. So hope you've enjoyed learning. Bring your name, Apollo's son. Always good to see him. Ophelia is watching in Normandy, France. Thank you, Ophelia. We've got a Russian, Bor Montagava, and Rich Jones, Carla Christian, Justin Crisafulli, River 1001, and Dave Stang. Of course, Dave's watching. And yeah, glad to see you, Cliff. He's the one that's in Pomona, Australia down there. And the Smitties are on there. Thank you, Smitties, for staying curious. We appreciate y'all. Can't wait for you to come back here. So, Marty, we got another week started here of Stay Curious. Believe it or not, folks, this is close to our 500th episode, edging up on a full 2 years of helping you stay curious. And once a week on Mondays, we help you stay star curious with some backyard astronomy. So hope that you learned a lot about our sun. This is what it looks like. The human eye just sees it like over my shoulder right here where my microphone is. That is the natural view. And all the others are different ways that science decipher this star, okay? It's not just the sun. That's the name that we gave it. Egyptians called it Ra, and all kinds of names for it throughout history. But this is our star, our most favorite star, just like all the stars in the sky. If we could go to one of the planetary systems that we're finding in nearby stars, our star would just look like one of the bright ones up there in the sky. Yes, Marty?
Adamus is watching.
Adamus. Adamus. Okay.
No S.
Okay. Adaba. Okay, Marty. Well, thank you very much. We're glad that everybody's watching us on YouTube, Twitch, Spotify, and what I leave out? YouTube, Facebook, Twitch, and of course Facebook. We got started on Facebook, and thanks to Jessica Galloway, our Trekkie techie, that's just always a phone call away. We called her at the last minute for one little Trekkie thing, but Marty's done a wonderful job doing our Streamlabs production in a computer here in our studio, right here in downtown Titusville. So please make plans to come and visit us. You will not regret it. I mentioned earlier that we had guests here, Marty. Where are y'all from?
Connecticut.
Connecticut. All right. Dave and Sue. You guys near Dam? Hello there. Welcome to our program here.
They work with Pratt and Whitney.
I work at Pratt and Whitney. Okay, great. But here I am in the patchwork of the sun, and so thank you all for staying. We'll talk to you a little bit afterward. Hope you enjoyed our museum here. There, very good. All right. Well, until tomorrow when we bring you some space history and some more space news and maybe an astronaut birthday. Until then, on behalf of our wonderful museum right here in downtown Titusville, we hope that you can visit us soon and bridge the space between us.